About 66 million years ago, Earth was a green, warm, and life-rich planet.
The global climate was stable then, rainfall was abundant, and vegetation thrived.
Forests covered most continents, allowing diverse ecosystems to form. Wetland areas played a crucial role in maintaining ecological balance. Plants were the foundation of the food chain in the Cretaceous period. Terrestrial ecosystems reached a stable state, lasting millions of years. This stability allowed species to adapt deeply to their habitats. There were no signs of an impending global event. In the ocean, marine ecosystems also maintained a similar state of balance.
Life on Earth, at that time, was not interrupted by major events.
However, Earth does not exist independently in space.
Asteroids continuously moved in their orbits around the Sun. One of those objects was approaching Earth's orbit.
At this time, life on the planet remained completely unaware of the potential danger.
This prolonged stability made Earth particularly vulnerable to a sudden event.
In the solar system, millions of small objects moved in stable orbits around the Sun. Most asteroids are concentrated in the belt, located between Mars and Jupiter. Occasionally, gravitational disturbances can alter the orbits of some objects. These small changes can cause an asteroid to leave its stable orbit. The object being observed has an estimated diameter of about 10 kilometers. The new orbit of this asteroid gradually intersected with Earth's orbit. Earth was still rotating at its normal pace then. On the surface, ecosystems continued to function as before. No changes were recorded in the habitats of the species. However, the distance between the asteroid and Earth was decreasing. This object moved at tens of kilometers per second. At this speed, the impact energy would be extremely high.
The asteroid passed the Moon's orbit without significant deviation.
Earth's gravity began to exert a stronger influence on the object's trajectory.
At this point, the asteroid was heading straight into the atmosphere.
The impact point was identified in the area now known as the Yucatan Peninsula, Mexico.
As the asteroid approached Earth, it began to interact with the upper atmosphere.
The air in front of the asteroid was compressed and heated rapidly. This process caused the object's surface to glow.
On Earth's surface, the environment had not yet undergone significant changes.
The asteroid moved at an estimated speed of over 70,000 kilometers per hour. A powerful shock wave formed in front of the asteroid. The light from the object surpassed the intensity of the sun in this area. Life on the ground had not yet reacted to this change.
At this stage, no natural mechanism could deflect the object.
The surrounding air was ionized, creating extremely high temperatures.
In a few seconds, the lighting conditions changed completely.
The ocean's surface reflected the energy from above.
The moment of impact occurred almost instantly.
Water at the impact point was almost instantly vaporized.
The energy released was equivalent to hundreds of millions of megatons of TNT.
This was one of the largest energy events in the planet's history. Immediately after the impact, a colossal column of material was thrust back into the atmosphere.
The shock wave propagated at speeds far exceeding the speed of sound.
Surrounding areas experienced tremors equivalent to extremely powerful earthquakes.
The impact energy activated multiple geological fault systems. The impact energy activated multiple geological fault systems. In the ocean, energy was directly transferred into the water mass.
A series of tsunamis began to propagate across the oceans.
Coastal areas at very long distances were also affected.
A portion of the material was ejected into the atmosphere before falling back to the planet.
Upon re-entry, these fragments heated the atmosphere over a wide area. Dust and gases were lifted high, beginning to disperse in the atmosphere.
The amount of sunlight reaching Earth's surface rapidly decreased. Upper atmospheric temperatures rose sharply for a short period. The planet began to enter a phase of global environmental transformation.
Terrestrial ecosystems were simultaneously affected by multiple factors. Marine ecosystems also began to undergo major changes. These consequences unfolded within hours to days after the impact. After the impact, a large amount of dust and sulfur gases persisted in the atmosphere for a long time.
This dust layer severely reduced the amount of light reaching Earth's surface. Global temperatures began to drop for a short period.
Plant photosynthesis was widely disrupted. Plants, the foundation of the food chain, began to decline rapidly. The decline in vegetation led to a food shortage for herbivores.
Large herbivores were severely affected during this period.
As herbivores declined, carnivores also lost their food source.
In the ocean, the reduction in sunlight disrupted the marine food chain.
Plankton, the foundation of the marine ecosystem, drastically decreased in number. This disruption rapidly spread throughout the entire marine ecosystem.
Within a few thousand years, a mass extinction occurred across the entire planet. Approximately 75% of species disappeared. This event marked the boundary between two geological periods. The era of non-avian dinosaurs officially ended. The planet entered a prolonged period of darkness and ecological restructuring. Not all life disappeared after the extinction event. Species living in caves, underground, or in water had a survival advantage.
Small mammals were among the important survivor groups. Insects, with short life cycles and high adaptability, quickly recovered.
Some bird species, direct descendants of dinosaurs, continued to exist.
Pioneer plants were the first organisms to recolonize the land. They facilitate the recovery of soil and the food chain. Over time, new ecosystems began to form. The marine food chain was gradually rebuilt.
No more giant species dominated the ecosystem.
This created opportunities for new groups of organisms to flourish. The planet recovered, but never returned to its former state. The impact event 66 million years ago was a turning point in Earth's history.
Traces of this event are still preserved in rock layers worldwide.
The unusual presence of iridium is important evidence for the extraterrestrial origin of the catastrophe.
The Chicxulub impact crater still exists, though covered by sediment and the ocean.
This event did not just affect locally, but impacted the entire planet. After the mass extinction, biological evolution proceeded in entirely new directions. The decline of dinosaurs allowed mammals to diversify. Today's ecosystems are a direct result of those changes.
Life on Earth is resilient, but not immutable. Extraterrestrial objects continue to exist in the solar system.
Today, science allows humans to monitor and predict potential dangers. However, history shows that Earth is always affected by external factors. Current ecosystems still depend on the stability of the global environment. Understanding the past is a way to prepare for the future. The story of the dinosaur extinction is not a story of an end, but of change.